All right, so a little bit of review that we're going to start with in this lesson here. We know that one way to create a linear equation for a linear function, okay, is using the slope and the y-intercept. So this here, right, this is our m, this here is our b, and so we know y equals mx plus b. That's our way of coming up with an equation. We call that graphic form. But, okay, the y-intercept, okay, is not always a nice number or possible to find. In other words, it's not necessarily always a whole number or an integer. It might be off the graph if we're given a graph, or it might just be some random number that is somewhere. Okay, we might not know where it is. So let's take a look at this one right here. Okay, so we have an example here using graphic form of a linear equation. Okay, and this needs to be changed here. This should be graphic form. Okay, of a linear equation. So we can find the slope. Okay, that's not that hard. We have 2 points. We have this one up here, and we've got this one down here that we can solve, that we can use. This is the point 3, negative 3. This is the point 6, 4. Okay. We have a rise of 1, 2, 3, 4, 5, 6, 7, so negative 7, and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9 of 9. So we have a slope, again, rise over run, negative 7 over 9. Okay, we have our slope. That's really nice, right? When we're dealing with our equation y equals mx plus b, our slope would slide right into m there. Now, what is our y-intercept? Well, our y-intercept is this point right here. It is not on 0, it's not on negative 1, it's somewhere in between. We could say that it is approximately, b is approximately, I should say it that way, negative a half, maybe, possibly, who knows. As the y-intercept is not a nice number, okay, we can't find it exactly, we're going to use something called slope point form. Sorry, I should have kept it on there. Slope point form in order to create an equation to represent the function. Okay, so we're going to use something called slope point form in order to find the equation to the function. Now, a couple different ways that we're going to, or that we can look at it. But what I'm going to do is I'm going to use this one here. Y is equal to m x minus x1 plus y1. Okay, so we're going to use this form right here. This is going to be our slope point form that we are going to use. Now, m, again, is the slope of the line. And x1, y1 is any point along the line. Okay. Now, here we had 2 points, right? We can use any point. If there's other points that we find, we could use those as well. So the point that we use doesn't really matter. Okay, so we're going to use this form right here in order to solve. All right, so for this, we need to know what the slope is, and we need to know what x1, y1 is. Okay, x1, y1 is any point on the graph. There's a couple different ways that we can do that. We have our slope, all right, negative 7 over 9, and I'm going to use both of them, 6, negative 4, sorry, it's negative 6, positive 4. Let's get that correct. Okay, we have that point, or we have the point 3, negative 3. With the point negative 6, 4, we're going to plug it in here. Y is equal to, our m is negative 7 over 9. X is going to stay the same. Now, x1 is going to become negative 6, and so we're going to subtract negative 6. And the y1 is 4, and so we're going to add 4. And it looks like that. This one here, y is equal to negative 7 over 9. X, now the x1 is 3, so we're going to subtract 3. And the y value is negative 3, so we're going to subtract 3 from there. So this is how we would solve for our function or create our function. Now, what we can do with this here as well is if we are subtracting a negative, it's the same as adding. So we could actually modify this one here to y is equal to negative 7 over 9 x plus 6 plus 4. And you'll notice that the x value, we're going to switch the signs in order to solve that. Okay, that's our equation. Okay, we use the slope and we use any point along the graph in order to find the value. Now, once we have an equation in slope point form as such, okay, we can use it to do whatever we need. Okay, so it can be used to solve the linear function. Okay, we can use it. We can, if we have an x value, we can plug the x value in. If we have a y value, we can plug the y value in, and we can solve for the other. The equation can also be simplified into graphic form to make it look a little bit what we might consider nicer, and then it spits out our y-intercept as well. So I'm going to simplify the previous one, and I'm going to do it in a couple different ways. One of the ways will be just on a blank piece of paper, but I'm going to use one of these and simplify it to our graphic form. So the first thing that we're going to do, we're going to take the top one here. Y is equal to negative 7 over 9 x plus 6 plus 4. We're going to take that. And then we're going to multiply the slope through the brackets. So we're going to take the slope and we're going to multiply it through the brackets. So it becomes y is equal to negative 7 over 9x minus, now 7 times 6 is 42, so it's minus 42 over 9. Right? Which we could probably simplify. I won't simplify quite yet. No, we could actually simplify. I will simplify it and then add 4 when we do that. 42 over 9 simplifies. We can divide them both by 3. We can do it with our calculator if we want to. 42 over 9 becomes 4 2/3. Okay, so this is the same as y is equal to negative 7 over 9x minus 4 2/3 plus 4. Okay. I changed it into a whole number, which is fine too. Okay, the next step, then what we're going to do, so what we're going to do next is we're going to add the like terms to simplify the equation. So we have these two that are alike, negative 4 2/3 and positive 4. So y is equal to negative 7 over 9x. That's going to stay the same. Now we can do that on our calculators if we want. Again, being 4 2/3, I'm going to make, I got to do it the opposite way here. Negative 4 2/3 plus 4 gives us negative 2/3. So it's minus 2/3. And once we have done that, the result will be in graphic form. You'll notice slope, y-intercept. Y-intercept is actually negative 2/3. I guessed it was negative 1/2. It's more like negative 2/3. Okay, but now we have it in graphic form. So it automatically spits out graphic form of the equation, and we can use that to solve. Now, we're going to get the next page in here. Okay. Given the graph, describe the linear function in slope point form, and then also describe it in the linear function in graphic form. Well, for graphic form, we need to know the y-intercept, and you'll notice that the y-intercept is somewhere between negative 2 and negative 3. We don't know exactly where. So we're going to first put it into slope point form. So remember, y is equal to mx minus x1 plus y1. We're going to put it into that first. So the first thing we need to do is come up with the slope. Oh, sorry, I apologize. I went one step too far here. I'm gonna take this here. I showed you how to get this into graphic form. But I want to show you that it doesn't matter which one we take, we're going to get the same form. So I'm just going to put this on a separate piece of paper and go through it quite quickly. Okay, y is equal to negative 7 over 9, x minus 3 minus 3. Okay, this was the other one that we had, okay, from just a little bit above. We multiply through, y is equal to negative 7 over 9, x plus 21 over 9 minus 3. 21 over 9 is 7 over 3. Okay, so y is equal to negative 7 over 9, x plus 7 over 3 minus 3. 7 over 3 minus 3 is negative 2/3. So this combines to negative 2/3. Y is equal to negative 7 over 9x minus 2/3. Okay, gives us exactly the same value. Doesn't matter which point we use, we're going to get the exact same equation. Okay. All right, so we describe the linear function in slope point form. We're going to do slope 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. So our slope is 9 over 6, which is equal to 3 over 2. And we don't know our y-intercept, which is just fine, but we have these points. This is negative 1, negative 4, and positive 5, positive 5. 5, 5. Okay. 2 that we can make here. Using the point 5, 5, because I like positives, y is equal to 3 over 2, x minus 5 plus 5. Using negative 1, negative 4, y is equal to 3 over 2, x plus 1 minus 4. You'll notice I just switched the signs for our x value, but that gives us our equation. Now we can switch it into the graphic form. We can use either one, doesn't matter. I'll use the top one just for the sake. Actually, you know what? The bottom one looks pretty nice because it has that 1 in there. That's nice. All right, y equals 3 over 2, x plus 1 minus 4. Multiply this through the brackets. Y is equal to 3 over 2, x plus 3 over 2 minus 4. We don't have to simplify that one at all. 3 over 2 minus 4 is negative 2.5. So y is equal to 3 over 2x minus 2.5. Or if we keep that as an improper fraction, y equals 3 over 2x minus 5 over 2. And I just converted. This is roughly, this one here would then be 0, negative 2.5, okay, or 2.5. So that's a way of making it in graphic form, converting it into graphic form. Okay, creating a slope point, making it into graphic form. Okay. Now, what if we want to graph something out that is given in slope point form? And this one, I apologize, is in a slightly different form. What I'm going to do is I'm going to add 2 to both sides. Y is equal to 1/3 x plus 4 plus 2. There we go. I'm going to put it into the proper form. It's the way I used to organize it, where I put the y1 there, but I'm going to put it on this side. When we see this here, we got to figure out what our slope is. That's this number right here, 1/3. We got to figure out what our point is. Okay, so our point is negative 4, 2. All right, once we know that, we're going to plot our point. Negative 4, 2 is right here. And then our slope is 1/3, so we're going to go up 1 over 3. So this is going to be our next point right there. And we're going to draw a line through those points. And that is graphic form. This is negative 1, sorry, that is negative 1, 3. That is our line drawn out based on our slope and our point. As long as we can derive where those are from, we will easily get it. If you see a question that it has y minus or y plus something, just add or subtract the number onto each side to get it into slope point form. Make it a little bit easier. Now, if you're following along in my class, your assignment for today, or for this section right now, will be LI 0.05. We're going to do numbers 1 to 4.